Hello everyone, this is a brief video to explore and present refraction of light, of which a rainbow is an example. We've been exploring rainbows and how rainbows contain all the different colors that we know, that our eyes can see. And we've been exploring how Isaac Newton showed that the different colors exist already inside the white light. And he showed how instead of the prism making the different colors, the different colors are inside the white light already. And when they pass through the prism, the light that exists in the colors that exist in the white light are going to bend at different angles. Now, the fancy science word of bend is the word refract. And red is a slow frequency, which means a large frequency. And the red is going to refract at a small angle because it's slow, it's a lazy color. But the violet is a fast color, is a short wavelength and a high frequency. It bends or refracts most compared to the other colors. So the red is the slow one, and as it goes through orange and yellow and green and blue and indigo and violet, the speeds increase, the frequency increases, and therefore the angle increases. And because the angles are different, that's what makes the colors look split, and that's what allows us to see the different colors coming out of the white light. Now, that is an example of refraction, and I'm going to show you different other examples of refraction. You see here I've got a glass of water and a ghost stone. Now, the water has a different density to the air, and so if I put the ghost stone into the water, there it is, and the light's coming from the stone up to my eye, but as it bends at an angle through the water, from the stone through the water into the air, it's going to bend. The light from the stone's going to bend, as well as all the light coming through the glass. You can see that interesting effect from the wall behind it, because the light from the wall is also bending through the glass at interesting angles because it's a round glass. And then here it looks like the ghost stone disappears. The ghost stone's disappearing, and there it's slightly visible at the bottom, all the light bending. And here's another example. If I draw a circle with an X, and I take a glass of water and I put it on the X, I can see it if I go there. But as I bend the camera there, I can see it in the background here, but when I look through the glass, it seems to have disappeared down there. It's visible if I look through the top, that there's a reflection effect happening, but it disappears. And there's this illusion of it disappearing because the light coming from the X, which is under there, is being bent away from my eyes. So here is another example of light bending. It's the famous mirage of someone who's very thirsty and in the desert somewhere, and walking for days and days and days, and sees in the distance some water. But in fact, this is light bending. It's a reflection of the sky, and even here the mountains, a reflection of the mountains. There's a reflection of the sky on a long distance road trip. It's just the heat of the air is making the air bend the light. So we end up seeing a reflection of the sky in the road. It looks like water in the distance, but in fact it's the picture of the sky. There's another picture of it. It looks very much like water here, but in fact it's just the sky, a reflection of the sky and the trees in the distance. So what's happening is that the light is coming from the sky down towards the ground, but instead of hitting the road, it bends up to our eyes. And when we look back down that ray of light, our eyes imagine we're looking in a straight line, so we see the road. But in fact, what we're seeing is the sky. Another example of light bending is where sunset tends to look a bit orange. Instead of the white light coming from a sun, the light bends as it comes through the atmosphere. When it's coming at lunchtime, the sun is coming straight through the atmosphere, so that it only has to travel a short distance because the atmosphere is quite narrow. But when it's going at sunset or sunrise, it's traveling through a lot of air, and the atmosphere has a lot of gases. It's got oxygen and nitrogen and argon and even pollution and water, very importantly, water vapor, that it travels through all these gases and needs to go through them before they reach our eyes. And because it's the atmosphere acts like a prism, so when the light travels through the prism of the atmosphere, it bends towards our eyes. And as it bends, it splits, just like Isaac Newton splitted light into all the different colors inside white light. The atmosphere splits the white light into all the different colors. All the purples and the purples, indigos, blues are all sunk down, shining down into the ground already. And we are only left with a very slow light of red. And that's the last color that's reaching us. And so we see the orange, the end of the spectrum. So I'm hoping that's helpful. We've looked at different examples of how light bends through a different medium. It might go through air into water and back into air, or air into glass like a prism and back into air, or through a vacuum in space and then enters the atmosphere of gases of air and then into our eyes. So water might be a different medium, but it's going from one medium with a certain kind of density into a different density, and that causes the light from the source, like a sun, to bend before it comes into our eyes. And when it comes into our eyes, we look back at through that ray, and we imagine it's going through the straight line. And so as we look down that straight line, down that light ray coming into our eyes, we look back down, and it looks like we're looking at the road, and there's sky up there. Hold on, we're not looking, our eyes and our brain doesn't realize we're looking that way. We're just looking that way, and that's why the road looks wet, or the light gets bent, or the stone disappears, or all these are very strange illusions happen, like the mirage and the fork getting bent, for instance. I hope that's clear. I hope that's clear, and I hope it opens new questions for you of what exactly is going on. Maybe you are almost getting it, but not quite. Please think about some questions that you can present to me tomorrow in our lesson at 11 o'clock. What questions come to you about this refraction of light? Maybe you notice new examples where light gets bent. Maybe you have new questions about the rainbow, and maybe you have new questions about what Isaac Newton was trying to do, or how he was proving what he was proving in order to disprove Aristotle's idea of the color, and how colors of the rainbow and white light work together. See you tomorrow.